Okay, I'd like to demonstrate downloading LiDAR data from the Utah Mapping Portal, which in general is a really easy and accessible website if you're looking for elevation data for Utah in particular. But LiDAR is tricky because it's expensive to collect and it covers very small areas. So sometimes it's a little bit harder to track this data down. If we start back on the elevation page, we can go in here and we have access to the 10 meter and 30 meter data from the USGS, and then there's a list of LiDAR that's been flown and collected for Utah. The descriptions are a little bit general, so you do have to get in and look at the interactive maps. And I am looking for a watershed in northern Utah. So I'm going to go here first and view the interactive map and see if it's available. This maybe shows me what I need and maybe not, so I'm going to dig in a little bit more. But you can see that these pink areas and blue areas are the regions where LiDAR is available and specifically related to this survey. Let's get in and look at the map. And I know that I'm looking for a watershed that's just east of Ogden. Here's the Pineview Reservoir. And I'm looking for this little watershed right here, just east of this reservoir. So if I grab this and kind of just generally outline my watershed, it zooms to the area and shows me that there is no data available for this area. But it gives me the option to search for more than just this survey. So if I go in here, now it's saying, okay, select the product that you want. I still am interested in LiDAR data. But now I can define my area of interest, and we'll just go back and do that again. And maybe that, maybe that watershed was included in a previous survey. Here's our little reservoir, here's our watershed. So this is going to search all the LiDAR that the mapping portal has available, but it's still saying that there's no data found. That's kind of a bummer. One thing we can do is maybe just switch up where we're looking just to see if maybe it's something that we're doing wrong. Okay, right by Powder Mountain, this is a really nicely defined little watershed. So I'm going to go back and clear my search and then kind of trace the ridge line of this little watershed. And we do get some results here. We've got 3 different data sets that are available, 2 of them at 0.5 meter and 1 meter. So our bare earth DEM from the first result, it doesn't really say when it's from, but we can go to the web page, but it's showing us the extent. And you can see that within this yellow polygon, it only covers half of our watershed. So that isn't really going to work if we're trying to model something within the watershed. If we go to this one, it looks like it's covering the other half, which is interesting. So here's the extent from that one. And it looks like it might give us full coverage, but we need to understand where these are. So let's look at the web page, or when they're coming from, to see if they're comparable. So half of the watershed was surveyed in 2020, and the other half was surveyed in 2016. So they're 4 years apart. That may or may not be suitable for your analysis. That's up to you to decide. You would need to consider things like how the point cloud was processed to derive these LiDAR surfaces, if they were handled by the same crew, were all the same inputs and the processing protocols followed for each data set. What if there had been a fire that had burned, in between 2016 and 2020? Then, would they be comparable then? I don't know. It's up to you. It's up to the question. But it is possible that we could piece together a single LiDAR data set for this watershed with those caveats. The 1 meter looks like it's got a similar extent in that it only covers half of the watershed. So the moral of this story is LiDAR data is hit and miss. It is tricky to find something for a specific watershed. It isn't always available. There are a couple of other options. One is called opentopography.org. This is Let's see if I can find a map. I mean, look at that opening image, was so gorgeous. So Open Topography is funded by the National Science Foundation and is a great repository for LiDAR all over the United States. You can partner with Open Topography to share your open source LiDAR data, and I believe that all national NSF funded projects are stored here as well. So you can zoom into your area of interest and see the different types of LiDAR that are available. It's kind of interesting. Sometimes you can find overlapping areas that were flown at two different time periods. So sometimes you can get really nice comparative high-resolution data sets over time. So Open Topography is one, and then of course the national map from the USGS is another great resource for LiDAR data. The elevation products are where you will find the updated 10 and 30 meter DEMs. LiDAR is considered source data because it's the closest thing we have to the quote-unquote truth. So the original 10 and 30 meter DEMs are updated and improved every time LiDAR becomes available for a certain area. So we'll look into the LiDAR. You don't have to work with the raw point cloud data. You can work with surface models that have been derived and processed for you. Notice that it outputs automatically to a TIFF file. So for fun, let's zoom into Utah and just see what we can find. Okay, here's Pineview again, and we're looking for this little guy right here. So let's see if we can use a point and just place a point on our watershed. Yeah, so I think we're out of luck finding LiDAR for our watershed. But again, moral of the story, that's how you'd figure it out.